Hello, and welcome to Science Day 2021. I'm Michael, and I'm the Information Technology Consultant Lead at CSU Stanislaus Stockton Campus. I took this wood router and turned it into a robot, so let's see how it works. It's called a CNC machine, which stands for Computer Numerical Control. A basic CNC machine runs on three axes. The x-axis, which moves the machine left and right, the y-axis that moves the machine forward and backward, and the z-axis that moves the machine up and down. To start, we need to create our design in CAD/CAM software. We will first create our design in the CAD, Computer-Aided Design side of our software. Now that our design is complete, we will move to the CAM, Computer-Aided Manufacturing side of the software. This is where we will create our toolpath. The toolpath is a set of instructions the computer will send to the CNC control board, which instructs the stepper motors on which direction to move. Once the toolpath has been created, we can view it in a toolpath simulator. This will allow us to verify our design and toolpath and see if any corrections need to be made. If corrections do need to be made, this is the time to make them. Once the simulator is complete and we have verified our toolpath, we will be able to move this around in different angles to be able to verify everything. After ensuring that our toolpath is correct, we will save our toolpath and we are now ready to move to the CNC software and run our toolpath. Now that we are in our CNC software, we first need to zero our X, Y, and Z axes. Next, we need to load our toolpath. So as you can see, we have our toolpath here, and we have our machine instructions here, also known as G-code. Once our axes have been zeroed and our G-code loaded, it's time to start the machine. So as you can see here, we have now started carving into our wood. This is known as V-carving. This machine will do several types of carving, but this here is known as V-carving. So for the sake of time, we're just going to speed this up because I do want you to be able to see this entire process from beginning to end. And this is a pretty long video. It's about 45 minutes if we were to keep this in regular speed. So we're going to speed this up. So I wanted to mention how I even got into CNC. So a couple of my hobbies, things that I do on my spare time, is I am a woodworker and a metal fabricator. And in the things that I do in regards to woodworking, I found that the tool that I use the most is my wood router. And at the time, I was basically just using it for woodworking. But I also found that I was doing a lot of repeat cuts. I do make things like cabinets, and I do some wood carving and that kind of stuff. And I found that I was doing the same thing over and over again, and I was looking for a way that I could increase my accuracy and at the same time have repeatability. And so I started doing some research and found that I could definitely get this with a CNC machine, because I can go in and I can make my designs, and it doesn't matter if I cut one or I cut 100 of them. They're all going to be exactly the same, which is exactly what I was looking for. So I started doing my research and really trying to figure out, what does this entail? So most CNC machines at this time were mainly used in industry. This is how companies can actually manufacture things at a high rate of speed and be able to manufacture the same thing over and over again. This is what I was wanting. This really sparked my interest and something I was really looking for. Then I saw the price of what a CNC machine actually cost. So these CNC machines for the basic hobbyist can run anywhere from $5,000 to $10,000 on the low end, up as high as $100,000 on the high end. This was way far above my budget, but I wasn't going to let that stop me. And so I decided to continue researching and find out, how am I going to accomplish this? So I ended up finding a makers group that actually make CNC machines, 3D printers, these kinds of things. And this was right about the time when 3D printers were really starting to come into the hobby world, and people were buying 3D printers for home. And so I wanted the same sort of thing, but in a CNC machine. So I found a few people that have done this already and had conversations with them, did my best to listen to what they really had to say and learn about what worked for them, what didn't work, things to avoid, these types of things. Now, for me, this was roughly an 8-year process. But that's only because I went through several revisions on the way. Originally, this was a machine that I designed that was about 2 feet by 3 feet. And as I started designing this, and as I started thinking about what I was really going to use this machine for, it went from a machine that was 2 foot by 3 foot to 4 foot by 4 foot. So this is a machine that I designed from scratch. It's my own design and built by me. There was a lot that went into this. I'm still in the testing phase. This was one of my first designs that I had created because I'm still also learning the creation side of it. The biggest learning curve is going to be your design software. So this was one of my first designs, and it came out fairly well. Now I still have some testing to do. I still have some additional tweaks to do to it to really dial this thing in. I know it can be a little more accurate than what it is, but at this stage of the game, I am happy with it. Now, by doing this, this also increases what I can use my wood router for. So not only can I now use this for wood, I can use this for several other types of medium or material. This machine will not only just cut or carve wood, it will also cut or carve any non-ferrous metal, such as aluminum and nickel, tin, brass, copper, silver, any of those non-ferrous metals. It will also cut all types of plastic, such as plexiglass and polycarbonate. There's also another tool that I can add to this, which is called a drag knife. Now, a drag knife will allow me to cut paper or sticker material, kind of like the stickers you see in the back windows of vehicles that people put in the back window of their car. And I can also cut fabric with this as well. So for an example, if you were trying to cut out a pattern for upholstery because you're going to reupholster a chair, or maybe even your upholstery that might be in your car, this will cut out your patterns, so long as you use a drag knife. Now, also, there's some other upgrades that I would like to do to this, but like I mentioned, I'm still in the process of learning the software and all this, still trying to dial this in. But they do make a kit that is available that I can attach to this CNC machine to turn this into a laser engraver. Now, as a laser engraver, I can engrave some pretty small things. I can then cut or engrave with, or even carve with a laser beam. So this really increases the usability of my wood router. It's nothing more than changing the bit in the wood router. Now, I can also carve in glass as well. This will also carve out photographs. So I can take a photograph and carve it out in wood, which are some pretty cool things to do. So it has really increased what I can use my wood router for, and it's not just for wood anymore. So I just wanted to make that mention. So now that we're coming to the end of our carving, what I'm going to do here is I'm going to slow this down so that you can see the end result and so you can see how this works when it gets to the end of its instruction set. So once this completes all of its code and it completes the last line of code, what it's going to do is return itself to its original position, which is its 0 position. And this is the end result.